Another important factor of the lighting, which you'll notice with all the fixtures, is they're all installed at the same elevation. We also are careful to be sure that they don't conflict with the beam themselves. And they're slightly below the beam height on the low side. And then from that elevation, everything's run true across. Because of the type of fixture angles that are created, if we ran the lighting up with the elevation changes of the building, we'd find that we'd have excessive shadowing and an uneven lighting pattern over the rink area. You'd have hot and dark spots. There's one area of the perimeter that hasn't been poured yet, just for coordination of getting equipment like this in without potential damage to the concrete perimeter to do the rough grade. What kind of fixtures are you using here?
Metal halide.
Metal halide? These are Hubble brand, aren't they?
Yeah. You from Hubble?
No, I'm from Burley Rink Supply. I'm the guy putting the building up.
Oh.
Just trying to show people all the crap we go through to put these things up. Huh?
Hey, shitting.
You guys putting the bulbs in now as well? Or are you
Yeah,
gonna do
we're
that
doing
later on?
everything. We go up or we're done.
Okay, and just bag it? And
Yeah.
keep that. How do you guys deal with the aspect as far as, I think there's an adjustment on this thing, which I'm showing right here?
Manufacturer.
They do that from the manufacturer?
They tell you whatever, yeah. This base is here.
Right.
It tells you on there like A, B, C, D, F, G.
Okay.
And they tell you where to set it.
And that's based on what, height off the floor?
No. No. It's based on the spread. The beam spread.
Okay, which I would think would be contingent off of the height of the floor too. Distance between the fixtures and the height off the floor.
They probably figured that. They probably figured it out.
Yeah.
We don't know that. It's a medium spread.
Okay. Sounds good. Some of these fixtures have a restrike option too, don't they, in case of a power blink?
You're looking at one right there.
This is a restrike?
Yeah.
How can you tell that this is different from regular one?
There, you got a little bulb.
Because of that plug?
No quartz bulb.
Look inside it.
See inside?
Look inside.
Okay, hang on a minute here.
Two sockets. You see
Socket?
Okay.
The little one.
Okay, the little one's the restrike fixture.
Yep.
And how many of them are there on this project? Like 6 to 8 of them? Something of that nature?
Throughout the job, yeah, but out in the ring, there's 4 of them.
4 in the rink area? Okay.
4 in the ring, 4 in that ring, and 2 in here.
And what kind of bulb is that? That's just
400 metal halide.
the little one is too?
Oh no, that's
That's going to be a
Little quartz bulb?
Ship it, man. I don't know what it is.
Okay, so that's not here yet.
no.
Okay.
We'll probably read on here.
Sounds good, sounds good. Here we are in the mechanical room. The refrigeration unit will be located right there. The Zamboni, of course, will be parked over the snow melting pit right in this location where these fellows are working at. And then the electrical is located right here. Here's where your primary voltage comes in from the outside transformer, which is located right outside this wall. Right there's the stairwell to the second floor. And they brought their power right in at this location. All the switchgear will be located on this wall as well. The reason for keeping it in with the refrigeration room is it eliminates the need for a separate disconnect for National Electric Code. That's within 50-foot inside pool, so you can run power right from the distribution panel right into the chiller without the need for a separate night switch. And they've got a low voltage step-down transformer from the 480 down to a 120 service, which is located right here. We've made efforts to take conduit and run it from our sound booth over to this location, and the reason for that is so we can control all the lighting within the rink space from low voltage lines that will run from the music room area as well as operating it here locally. See here on the parking lot that the parking lot's been graded. They're going to be bringing the gravel in next week. They've already went ahead and commenced and have a good bit of the concrete curbing done around the perimeter. You see that there, one little section. They used a curbing machine for putting that in place. The machine knocks it out in no time at all. And ran that whole way around the perimeter. See, they've got their gravel delivered. They'll be laying that out and compacting that. Here the masonry for the core is very well underway, almost completed. You can see here in the background that travesty we had this morning, where fortunately nobody was hurt. You can see that one beam fell, and that dropped the other hollow core, and we're finding out that it appears to be a structural design error in the support of that beam. That may hurt our schedule by a couple weeks. Tough to say, it just happened this morning. Do you know what kind of compression rate you usually use for the curbing? I know you guys pour it real dry, don't you? So it comes out of the machine properly?
Yeah.
Not really sure, huh? You guys use anything? Is there anything like a fiber mesh or anything like that in the material?
They never asked for it on this job.
No?
Nope. They'd put it in if they asked.
Yeah, understand.
Yeah.
Or rebar, if they wanted it.
Uh-huh.
We'd put it in, but
Okay. The curbing that we used here is a 4,000 PSI mix. It doesn't have fiber mesh in, nor does it have rebar in it. Typically state jobs will dictate that, but for commercial applications it's really not required. It adds cost to the project, and the curbing is something that's put in because local ordinances and codes dictate that there has to be a curbing around the parking lot. It certainly doesn't help the bottom line in any fashion. And what you guys have done now? You have a good bit of it, don't you?
Yeah. It's pretty much done. We have a little bit on the back yet.
Mm-hmm.
The field ends.
And you do it by hand around areas where the machine just won't work for you?
Yeah.
It's just basically too small, it doesn't pay for the
Yeah.
setup? And
No, we can't set up.
And how about the different elevations? Do you do that by hand always, or can you do that with a machine too?
Well, the machine does it all by elevation. We
Uh-huh.
set everything by string line, and that's the elevation, and then we just set off, with the curve.
I guess we have some ramps shown right here for the sidewalk area or something of that nature. That's where we have those two dips, I guess, huh?
Yeah, it's wheelchair.
Okay.
Wheelchair
ADA
ramps.
stuff. One of the important factors with any of the concrete work is base material. You can see the type of gravel they put down compacted for below the curbing, and that will also take place over the whole parking lot area. Here the parking lot's being prepared for asphalting. The base is going down. Here the parking lot's ready for pavement. That'll be taking place this following week. We wanted to get that done before the weather turned bad. Today we're about October 30th, Halloween. Light poles are in place. Typically the lighting poles for the parking lot are rated at 3-foot candles for all places in the parking lot. That's the last footage shot on the project. See, here's the manufacturing side of the Training and Technology Center. An outside staging area here has been poured in concrete and is a good bit under roof. You can see we're moving right along now. Over at the center of the complex, we've continued to put the hollow core up, and we're almost completely done with that. This will be finished tomorrow. The rink area is being completed now as far as the grade. You can see the area where the rink will be placed is very well compacted and graded almost level. A little bit of finishing up has to be done yet. The curb's in all places except the area where they're doing the grading from, which is right here, and that'll be poured probably tomorrow or the next day. You can see the floor drain stub outs yet in that location. We can see on the far wall where the metal liner panel stopped, and we have plywood installed, and the reason for that is we'll be putting in 1/4-inch polyethylene sheeting over this area to protect it. The beams have started to be painted. That'll also be completed this week. Time I shot footage, this hollow core had fallen down from a construction area. It's since been reinstalled. This beam was determined to be the problem, that there was a structural design matter on this one beam where it rested on the masonry. It wasn't filled with grout, and also the beam wasn't long enough to distribute the weight load from the second floor area. See how the hollow core, after it's painted with a texture paint, will actually make a very nice looking ceiling. This will be the future rental skate room, and this is a portion of the arcade and e-space location that we're going to have in the Planet Ice Burley Rink Supply Manufacturing and Training Center. Over in this location is the future home of the concession area. Back in this door are locker rooms, both men's and women's locker rooms, because of the gain in women's popularity in hockey. Here we're standing at the center line of the ice rink, looking across where the red line would normally be, and you can notice by the grade how there's a depression right in the middle. This is a sand base installation with a permapipe system. The overall elevation decreases 9.5 inches. At the point where the header is located, we actually excavate the rough grade down to 19.5 inches, as you can see right here. Please consult with all Burley Rink Supply drawings and engineering specifications for your particular project, as design may modify these elevations that I give you. Here we're standing in the back side, which is basically the manufacturing entrance and parking lot for the manufacturing area. Also the back side of the ice rink. The parking lot is beginning to complete readiness for paving, which they're looking to pave both sides at one time. Also shown here is the dehumidification system, which will be servicing the ice rink area, which will be maintaining a relative humidity of about 45 to 50% during all times of operation. We'll have detailed footage on how the ductwork and the sensor packages are put together for this system. This is a desiccant type dehumidifier, which works very effectively for low ambient conditions, which is conditions inside an ice rink. So here we have, we'll get into an additional footage of how the operation of this unit works. Here we're showing the parking lot. The parking lot's been fully paved and lined. Masonry work is just about completed. Front entranceway area, out rooms, bringing the rubber roofs on top of there. Inside the rink, basically this is the only open section of the building, the rink area. The last of the concrete around the perimeter has been poured today. You see the beams have been painted blue. They're not completely done yet.
Like time-lapse to beat.
They've all been painted. You see they have the laser set up here for the rest of the concrete perimeter. As mentioned earlier, the elevation around the rink edge is very, very important. Here we're in the back of the building, showing the dehumidifier. Masonry's up all the way. We've got our evaporative condenser and receiver skid in position. Getting ready to place the asphalt in the back here. One thing that's real critical, because it's November, to get the asphalt down before the hot mix plant shut down. Most of them will be shutting down in about a week. We had some soil compaction problems on this side that we noticed just before we were going to put the asphalt down, and they had to excavate and put some engineered fill in, make sure we have the proper compaction so the asphalt will last. You see everything comes as a skid. Here's the LPA pumps. They're responsible for an awful lot of energy efficiency. And the chillers inside as well. We'll go in and take a peek at that. Here they show where the dumpster is going to be located. They're always putting the dumpster on top of concrete because the wheels of it wouldn't hold up real well on the asphalt. We're inside the mechanic room again. Electrical equipment's in place. Chiller's in position. Covered with plastic. Try to keep it clean for right now. Pump skid still isn't here. That'll be delivered the next day or two. The boiler room, right next to the refrigeration room. Manufacturing side of the operation. Roof's going on pretty quickly now. Basically, it's the same type of roof structure we use on the other side. The refrigeration crew is starting with the placement and piping of the refrigeration system. Here's showing the turbo chiller and the pump skid, what we call the pump cat variable flow rate system. The crew is also beginning to do work out on the rink floor. Here they've got the subsoil heat tubing delivered. You can see the 3/4 inch polyethylene tubing that's used for the subsoil heat tubing. It's delivered in continuous rolls to eliminate joints in the rink floor. And also the subsoil heat header being put into position. Subsoil heat tubing is fed by a reverse return Schedule 80 PVC header. Here you can see the connections. We use a barb connection to stainless steel hose clamps for all the tubing. These are the Chlorovac radiant type heaters that will be placed over the bleacher area. They're gas fired. It'll be important that the exhaust on these goes outside. See what's here. (100,000 BTU an hour). How you guys doing? Before they start running tubing on the subsoil, they're going to be out here with a lift here real quickly to pull these bags off these lights. All the overhead work must be done before they start running the tubing. Here it shows the player's box floor has been poured. You can see how the slab is poured on top of another slab to create the elevated area for the player's box and the key. And the dashboard, of course, will sit right on that inside edge. And the whole floor can be covered with rubber flooring. Back parking lot getting placed after the poor soil conditions were dealt with. Fortunately, we're going to get all our paving done before the weather turns bad. Mother Nature's been pretty cooperative with us during the construction period. We're beginning to put the radiant heating up. over the bleacher area. They'll end up venting that up through the roof. We don't want to vent any gas-fired devices in the space because the natural gas, a byproduct of its combustion, is humidity, which is adverse to the rink. Here we show the subsoil heat tubing being finished. Essentially, this is a 3/4 inch polyethylene tubing located 18 inches on center over the entire rink. We have a more detailed subsoil heat video and complete floor installation video that's also available through BRS that gets into the details of the components and the installation methods of the tubing. The tubing comes in large spools, 2 continuous runs to minimize the amount of joints in the floor as much as possible. The subsoil tubing makes 4 passes back and forth across the rink floor. They're connected by means of a stainless steel hose clamp, double stainless steel hose clamp, and a reverse return header. The subsoil heating system will contain a glycol solution that has a freeze point at about 5 degrees positive. And the freeze point will be lower in temperature than the rink floor would ever be allowed to get from the ice sheet. The reason for this is should we have a thermostat or a pump failure of any type, there will be no chance of the subsoil system freezing and becoming inoperative. After all the tubing's basically been put in, the workers coming back and torquing down all the hose clamps, which will ready the system for a pressure test. The pressure test will be more than 3 times operating pressure, which is actually a very low operating pressure, maybe 10 psi. They'll be bringing the pressure up to about 40 or 50 psi, testing all the joints and sustaining that pressure during the entire fine grading process, which will consist of about a 3 to 4 inch layer of sand placed over the entire rink floor to a dead level condition with our laser grading machine. You can see little curls like are shown right here, right now. That'll all be taken out before the sand is placed over the tubing. You can see how the subsoil heat headers are off-centered from the depression in the middle of the rink. We're back in the mechanical room where the turbo chiller and the pump stat skid are in their final position. The service technician and installers are preparing the equipment for running the piping and mounting all the piping and the equipment. What are you doing, Denny?
Unistrut. I'm going to anchor some unistrut here.
Okay, similar to this piece that we have here.
Yep.
And all the piping will be braced off of that? You see already the installers noted where the wall penetrations and boring will be for all this refrigerant piping. We'll have a professional core driller come in and bore nice round holes with special boring equipment through the masonry. Outside sits the evaporative condenser skid and the receiver skid. Here we're on the manufacturing side of the facility again. You can see the roof's about 3/4 done. Another couple of days they'll have the manufacturing side fully skinned. They're beginning with mechanical work up on the 2nd floor in the corporate office area. I'm going to go upstairs so we can take a look at what the subsoil heating system looks like from above. Here we're in the corporate office area looking down on the full ice rink. And you see the uniformity of the subsoil heat tubing. This is located over the whole rink floor. As noted earlier, the tubing is located 18 inches on center. Other companies may put them as far as 24 or even as far as 30 inches apart. We feel because of the relatively low cost of the tubing and the possibility that one tube may take a little bit of a wave in its placement, an over amount of tubing certainly can't hurt, considering the importance of the subsoil heat system.
Complaining about that builder just stuck up in that.
I didn't stick it up there, Timmy did. Somebody did. Oh, you did.
He asked me if I did, and I denied it.
Oh, yes, I take the heat now.
Well, it's corrected. That's the way that little rod thing. That second house, the middle house, doesn't have one of those things. And I never put the clips on in the back because I didn't think.
During the initial design stages of the complex, it's important that the occupancy of the different rooms are rated to comply with the minimum hassles from a code standpoint for fire rating. For example, here we are up in the corporate office area, looking down on the ice rink. The other wall separating the offices from the manufacturing area. The initial occupancy rating, the way this was set up, was the rink was a public assembly occupancy. The first floor in the center core was a public assembly occupancy. The second floor, based on BOCA, was rated as a business occupancy. And then, of course, we had the manufacturing side. The problem with the upstairs being a business occupancy is the codes required a 2-hour wall on the separation between the offices and the ice rink. The difficulty with that was we weren't able to put standard windows in as far as a 3x4 1-hour firewall. They wanted a 2-hour firewall between the upstairs and the ice rink, which really critiqued our ability to put windows in. We have since re-petitioned for a re-designation of the second floor to also a public assembly, considering that we're going to have seminars and training taking place up in the business offices area, and they're rezoning this area as a public assembly as well. So we'll be able to have an ample amount of viewing areas, your typical 3x4 glass with a wire in it, looking down over the whole ice sheet, down this whole wall. If you're building just an ice rink itself, it makes a lot of sense to rate the whole common lobby area and the ice rink as a complete A1 occupancy. It reduces an awful lot of expense and construction hassle. On the second floor area, all the hollow core has been put into place. The joints between the hollow core have not yet been grouted. These will all be grouted first, and then the entire upstairs area will get a 2-inch skim coat of grout to create a power shroud level concrete floor surface. So here's the mechanical beginning to be installed. They need to put the ridge cap still on the structure, but all the installations in place. The beams will be fully painted to the point of where the wall is. There will be a drop ceiling over this entire area, so the beams won't be painted over this section. Right below where I'm standing will be the concession area. The concession area will require an awful lot of venting for the grills and that set of equipment up through a case and up through the roof structure. What is important here is that that's coordinated with the hollow core. If hollow core is used, if trusses are being used, obviously it's a little bit easier. The difficulty involves the amount of opening that you can saw cut or bore through a hollow core panel and still have it structurally be sound.